Welcome to the Valley Today, a public service presentation of KAIL-TV. Our journeys take us to Visalia to witness the launch of ethanol producer Edeniq, a biomaterials and sustainable fuels company, using advanced technologies to convert non-food feedstocks into high-grade ethanol. It's all next on the Valley Today. Welcome to the Valley Today. I am here at how do you pronounce it? Edeniq?
Edeniq.
Edeniq. Boy, I already screwed that up.
That's all right. We tried to make that tough on everybody.
And we're with Brian Tom here, and you are the president of Edeniq?
Yes.
Yeah, and from the Midwest.
Born, bred, and raised Nebraska.
And today we are talking about ethanol. We are talking about ethanol production, and you've got a new plant here in Visalia.
Cellulosic ethanol pilot plant, corn to cellulose migration.
Okay, so what's the migration part?
Okay, see, this is the pilot plant you see here is an example of how you take existing assets and infrastructure and transition components of them over time so that we're making ethanol, cellulosic ethanol, out of non-food biomass products.
Okay, so in other words, we're taking the food out of the equation now. You've already got the biomass from the stalks and all that.
Yep.
And that's what we're generating the ethanol with. That's what we're creating ethanol with.
That's what we're creating ethanol with. It's what normally is left on the ground and either fed to cattle and/or a soil amendment. So you can take a certain amount of that out of the ground and leave the rest in to make sure that you still have good soil quality.
There's a higher sugar content in the food, though. So when you're dealing with this the biomass stuff, you have a lower sugar content. Is that correct?
Which is okay. Different biomass has different sugar contents as well.
And this is what you guys are creating to.
So this is pelletized corn stover. So this is taking corn stover off the ground. You can do that here in California. You do that out in the Midwest. Pelletizing it, breaking it down, making sugars, converting that into alcohol.
And of course this makes this more easily transportable too, so you can bring it out of the field and you can bring it to the plant.
Transportation and storage.
Yeah. Now if you had a big enough farm, you could conceivably have this on your farm, couldn't you?
Conceivably. It'd take a lot of acres at that point, you bet.
Now, how many acres are we talking? You're talking about 2 tons per day to operate this plant here, right?
So
2 tons of cellulose of this material.
You bet. And so it depends on how much you take off your property. So different farmers in different locations take certain amounts of what we'll call the stover, the leavings, off of their soil. But it depends on how good their soil is, what part of the country they're in, what the year has been like. So that can change year in and year out.
And because you guys are dry farming in the Midwest, so it depends on if you get a good rain year or not, depending on how much plant material you can generate.
It's going to depend on the varieties and the particular year and whether it snows early or late, you bet.
So now we've got a lot of these ethanol plants already online in the Midwest, and what you say is the steel and cement infrastructure is already there. Now you're being able to take that and use just the stalks now, the corn stalks.
Use the stalks. So we can go in, what we do is we go in and add technologies to make those existing plants more efficient. So you take a corn ethanol plant and you utilize less corn to make the same amount of alcohol. Ethanol coming out of the production. Then we go in and we say, now let's take trains like what we have built here, and let's add that to the infrastructure such that we can take advantage, and maybe at a 100 million gallon plant, we'll make 5, 10, 20 million gallons of cellulosic ethanol alongside their existing infrastructure. Use even less corn.
Right. Now I come from a farming family. We grew tree fruit, and we're putting off at least 30% waste from going fresh pack.
Yep.
And I've always looked at the fruit on the ground in the field or on the roads and thinking what an incredible waste that is, because that is high sugar content.
That's just sugar going to waste.
That's just sugar going to waste. Now you can conceivably make booze with this too, couldn't you?
Absolutely. And I know, as a matter of fact, there's a company I've done a lot of work with in the past where they'll take about any kind of product that somebody would take them, and they had some real messes on their hands, but boy, they had fun doing it. So.
And their attitude improved as they were cooking it, huh?
Exactly. Amazing how that happens.
Yeah. So what's the future for this?
So we'll be conducting tests over the next year alongside the DOE and our partner Logos Technologies. And we're going to be working with corn stover, switchgrass, and woody biomass. Further to that, and we'll take this plant and we'll continue to work with additional California-based feedstocks from around the world. We're working with partners down in Brazil right now with sugarcane bagasse. And the goal for this is to test and make sure that we have as much data as possible coming out to it, make further improvements to the process, drive the economics, and produce a good, valuable drop-in fuel.
So will this be used commercially, the fuel, once you generate it, or is it going to go back to your partners?
Yeah, it'll go to one of our partners that we're working with. So we don't produce 100 basically 100% or 200 proof here.
Right.
We go to a certain level. As a DOB, Department of Energy backed facility, there are limitations to what we can do commercially with this particular unit.
Right.
What this is here to do is prove the commercial capabilities.
Yeah. Do you have any other plants like this that are operation in the Midwest?
There are a couple out there that are demonstration scale. Not us, of course, but some of the other companies that are working on it. Yep.
So Edeniq is Edeniq. Boy, that's a tough one. Edeniq is a fairly new company, about 4 years old.
About 4 years old. We're actually sprung out of an existing company that was here even before that. So our team has been working for about 7 years now on the process technologies in this area with the original corn ethanol plant from which we were spun out.
And that was one of the things originally when the ethanol got going in the Midwest, is that it seemed like it was driving the corn prices up because they were using the food. They were using the corn, and cooking that.
You hit on one of my favorite subjects because unfortunately, though, we could spend about 3 hours on the food versus fuel debate. And what I can tell you is, coming from a farm family background, off the farm corn farming, and having seen $2 per bushel corn, et cetera.
Right. Now, is $2 per bushel, is that high or low?
That was low back then. It was high, but if you look at it in the context of $6 a bushel today, but there's a lot of really interesting studies that a person can go out and look at. We produce a dry distiller's grain in the corn ethanol industry that comes out of this. So we're looking as well at what do we do to reduce the fiber content in that and make it a more valuable co-product that's higher in protein.
Right.
So there's other opportunities. That's a feed product that's put right back into the existing feed markets.
As you're cooking this, do you have what's the byproduct after you're done with it? After you're done with these pellets?
What comes out of that is a lignin product, which is essentially a fiber product. So that can be added back into rations as well.
Oh, okay. So you can put that back into feedstock and other things.
It can be. Right now, one of the primary uses of it, though, is it's got more value as a BTU, is burning it.
Right. Now, you'd mentioned also that you can conceivably take in forest products.
Forest products, switchgrass, sugarcane.
Right,
Yes,
and so the forest products, you can make ethanol with that.
We have. You mentioned you were in the citrus business. We've made a lot
actually
of
the tree fruit. Peaches, plums, nectarines.
Okay. We've made a lot of cellulosic ethanol out of citrus woods and things like that. So softwoods, we've worked with hardwoods and certainly citrus wood around here.
And has your science department done anything with the tree fruit itself? As I had mentioned earlier, we're throwing about 30% of that away, and high sugars. So
if somebody wants to give us the easily accessible sugars like that, then we're more than happy to work with them.
Because you see that trucked all around, and usually that's just getting thrown away. When you're going fresh pack and you've got scars on the fruit fruit's good, eat it, no problem. But there's scars on it, we can't ship it to the fresh market.
That's right. And one of the things that we're working with the California Energy Commission under a new grant program is on what other products and feedstocks in the state of California can be used. So look at every single opportunity from the ag industry all the way up through forestry, et cetera.
Now, with oil prices dropping, this is going to be a little more competitive for you now, I assume.
Economics are always going to drive
it. Of course, oil prices always rise and fall.
I was just going to say, it wasn't so long ago we all looked at it and said, boy, there's no way we'll cross over 100 in the very near future. And once we shot up as high as we did and then crossed back down, everybody said it'll be a long time before we reach over 100 again. And that didn't take any time at all to hit.
The internal combustion engine, they can ingest this fuel and burn it quite easily, right?
They can.
And the carbon signature has got to be lower using this than it is with
80%
gasoline.
Reduction, significant reduction using cellulose.
So what's next for you?
We will be starting a demonstration scale project down in Brazil. So this is about 20 times what our original pilot plant work was for this scale up for this pilot plant.
Right.
We'll be now going to a 10x scale from that, and then a commercial scale project immediately thereafter.
So commercial, how much will you be making a year with that?
We haven't announced it.
You haven't announced it?
We haven't announced it.
That's for you to know and for me to find out. And if you tell me, you'd probably have to kill me,
gives us reason to talk again in the very near future.
Well, this is really impressive. And you're going to give tours this afternoon of this plant.
Yep.
And for people that are more interested in Edeniq. I apologize. You guys, like you said, you came up with that name just to twist guys like me up.
It was a lot of fun.
Yeah.
We're at www.edeniq.com. Contact information there. So.
Yeah.
Yep.
And that's very good. Well, Brian, thank you for your time. Dean's a chemist. Thanks for being on our show.
I'm welcome. Happy to do that.
Yeah. Now, describe for me the sugar economy.
The sugar economy?
Yeah.
Oh, this country has a very large sugar economy, not necessarily in sucrose sugar, which what we eat, but it's sugar that comes from corn, comes from all sorts of things, and we're in fact, we call it a carbohydrate economy because we are really rich in carbohydrates.
Yeah. And you were a chemist. You've worked in the private sector your whole life?
I've not worked in the private sector. I've mostly worked in research, at university type research. I worked at DOE National Labs, and I worked for NASA for a long time.
Oh, what did you do for NASA?
I worked on, you'll enjoy this, I worked on food for space.
Yeah.
And I also worked on using carbohydrates and stuff to produce other kinds of materials for eating, and I worked on some NASA projects, flew a shuttle experiment in space doing radiation effects.
I was at the Museum of Flight in Seattle on Saturday looking at the Apollo space program and the foods that they were eating when they were going to the moon.
Right.
And it was pretty impressive.
Yeah,
it didn't look very appetizing, but it was impressive.
I was more involved in if you inhabited space.
Oh, okay.
If you lived on the moon, for example, how would you feed yourself?
Yeah, how would you generate your own food stock?
So that's what I was working on.
And now tell us a little bit about this plant here.
This plant here is what they call a pilot plant operation. It's to demonstrate a technology in an integrated fashion, because you can take the feedstock like corn stover or wood, and you can turn it into a fuel, and you can do that in the laboratory easily. It's just easy. You take one part and you mix it together. But here, you're talking about a scale, and the scale is big enough that you have to grind it up, you have to process it, then you ferment it, and you produce it, and you distill off the alcohol product. That has to be done in an integrated fashion, because if you don't do it in an integrated fashion, nobody's going to invest in the technology to make it into a real commercial facility.
Right. How much water do we need to generate 50,000? This thing processes 2 tons of dry biomass a day, which I figured out to be about 730 tons a year, 50,000 gallons a year of ethanol that this creates. So how much water do we need to be able to make that?
In corn mills where they're doing biomass corn, they usually try to get down to 1 to 2 gallons per gallon of ethanol. In this pilot plant, it will be a lot more than that because it's a pilot plant. They're not really worrying about water economy. But one of the things that will come from this is the basis for how much can we reduce the water, how much can we recycle. And that's one of the things they're going to look at here, is how much water can they recycle so they don't have to use so much water for each gallon.
Now, is the deal different here in California than it is in the Midwest? Because we did have all these ethanol plants set up in the Midwest, and I don't know, probably corn is the same here that it is there, but we're irrigating it here from water coming out of the Sierras, and in the Midwest it's all dry farming.
Well, they don't irrigate, they just let the natural rain come.
And then they have good years and bad years, so that's got to be able to affect the supply of when they get the corn, the cellulose material.
It is different. I have a project in Kansas, and the harvest in 2011 is much different than the harvest in 2012 because of the drought.
Right.
The composition's different, the water content's different, and so forth. So
the structure of the plant itself is different because of
slightly different, not hugely different, but it's slightly different.
So is this economically viable?
It will be.
Yeah.
I believe right now this plant itself is not economically viable. It just isn't, because the whole point of this is to find out what the processing parameters are, so that you can then say, okay, if this costs so much per gallon, do I really need stainless steel here? Maybe I can get away with carbon steel.
Right.
Do I really need to, how much water do I need to recycle to cut the cost down? And so those are the kind of things they will look at, and once they get those figured out, then when they translate that to a commercial plant, they can say, in a commercial plant, I don't have to recycle, I can recycle more of the water, so my water demand is smaller. I don't have to use stainless steel here, I can use carbon steel. Those are the kind of things they're going to find out.
Right. Now, how did they determine to set this up in Visalia?
Any project that came to us under this competitive solicitation had to have a site by which they were going to build a plant. That was a requirement. They had to have a site. So they apparently worked with Edeniq, apparently had decided this was a reasonable place to do it. Look at the cornfields out here.
Yeah, I know. To the north, it's all corn. But of course, it's all cattle too.
It's all cattle too.
Yeah.
And so
big hat, big cattle.
Big cattle. And so they try to pick sites that will have lots of feedstock.
Yeah.
And this was a very good one. The Central Valley, as you know, is one of the richest places for growing agricultural things in the entire world.
Yeah, the soil is good.
The soil is good here. You got reasonable water, good climate, so they can grow lots of agricultural material here. And so that agricultural material is just a ripe source of feedstock.
So what kind of acreage are you going to need to supply this?
I don't know the exact number, but I know that I couldn't tell you. I really can't tell you that number. I just don't know. I'd have to sit down.
And so they've had to partner with some private property owners to be able to get the corn from them, right?
Correct.
So are they paying market value, or
they're probably paying? They're probably paying more than market value because this is a pilot plant operation. But other projects that are building these commercial demonstrations, they are paying pretty decent prices. They're paying not only the price for the feedstock. Some of the people are paying. They're paying the farmer to. Will you promise me you'll grow this for the next 10 years? And I'll give you a subsidy every year to guarantee that you're going to grow it for the next 10 years.
So right now it's subsidized, but in the future it's going to have to be economically viable.
That's correct.
Which it probably will be.
Probably will be.
Now the carbon footprint for this stuff burning in an automobile engine has got to be way less than fossil fuel, right?
That is, it's way less. People argue that's a big argument now in the business, but usually, and do the calculation, it is lower than.
And it's a renewable energy source. It's not like the fossil fuel in the ground. There's only so much of that. They say there's a lot of it, and we won't exhaust it for another 100 or 200 years. But the point is that we will eventually exhaust it.
We will.
This is a renewable energy source.
Some people call it regenerable. You can regenerate it every year.
And you know, guys that are growing corn or growing tree fruit or whatever they're growing, you know, they're bringing the temperature down because, you know, the heat signature coming off a field it was interesting. I was driving through the countryside, and I went from the countryside into the city, and the temperature difference had to be at least 15 degrees.
Oh yeah, it's a big difference, and I think people don't appreciate it.
And it happened within a couple of miles.
People don't appreciate that.
Yeah, so the microclimates can really change depending on what you're growing. And
absolutely,
you know,
absolutely.
Yeah. Now, is the water supply here viable for doing this?
You know, I don't know the water supply here in Visalia. I'm sure it's adequate for this facility, but there are we have. I have a plant in Kansas where, you know, it's dry farming and it's irrigated farming, and water requirements are very specific. You can only draw so much out, so you know you have to be careful about where you go.
Right. And it was interesting. Brian was talking about the brick and mortar structures that are already in place in the Midwest, and so to be able to convert it to just this lower sugar chaff that's coming off. If you're harvesting the corn, I mean, that's either going for feed or going for human consumption, then you're just using the chaff now. But there's a lot less sugar in that.
There is a lot less sugar, and it's tied up in this matrix, which is why their technology here is kind of unique, because they use a combination of mechanical processing, what they call pre-treatment, and then they use some chemistry and biology to get the sugars free enough so that organisms can ferment it and turn it into fuel.
So take us quickly through how we get this stuff from the corn stalk to the pellets to into the plant and then making ethanol.
They take the pellets or the corn stalk, or they can even take it raw. They put it in and they grind it up usually to a very fine powder. If you go on the tour, you'll see there's some fine powder. They take that powder, they get it wet. Then they, in this case, they get it wet and do a little bit of a pre-treatment, kind of with a little bit of acid and stuff in it, not a lot. Then they run it through their cellunator, which is their intellectual property, which grinds it even finer. And so then when it runs into these, what they call saccharification tanks, that's where they put enzymes in. The enzymes are known to degrade these cellulose fibers into sugars. Because they use this special pre-treatment, this works a little faster than normal. Some of the other plants that are doing this, it takes a long time for all those steps, but this step goes pretty fast.
So you're accelerating the process.
They're accelerating the process, and they get the accelerated process, they get the sugars out, then they pump it into another tank in which they have introduced into microorganisms, or yeast they call it, and the yeast actually ferment the sugars and turn them into alcohol.
So a pilot plant like this, from field to pellets to the alcohol, how much time are we looking at?
They'd like to run this in less than 72 hours.
Oh, no kidding.
Yeah, not for the field. I mean,
but I mean, once the product's coming out of the field, then they can generate alcohol in about
72 hours.
No kidding.
That's the plan. They'd like to do it even faster, but they could like to do it in 72 hours or less. Some places are talking 90 hours, but because they have this front end piece, it goes a little faster.
So that's pretty quick turnaround.
It's actually pretty
I would assume, and of course I don't know anything about chemistry, but I would assume that it would have taken a lot longer than just 3 days.
No, it's pretty good.
Yeah. And have you done any tests in automobiles with this stuff?
Oh yeah, well, not this specific fuel here, but
Right.
it's certainly been tested in 100. EPA is doing all the tests.
What's the octane on this?
Octane for alcohol is about 110, I think, 115.
Yeah. But of course, the evaporation rate for alcohol is a little faster than it is for
The faster, it's
gasoline.
called the Reed vapor pressure.
And then are you guys playing with gasaline, mixing it with gasoline?
when you
and doing all these-
denature this, you have to denature it because
Yeah.
otherwise it becomes the ATF will get after you. So you have to denature.
What's that? Because they want their cut of the action?
That's right.
Yeah.
I guess, but so you have to denature it with
What's the
5.
tax ramification on just making ethanol for burning? Is there any tax consequences?
I do not know that.
Yeah.
I just know they have to denature with gasoline, so they put 5% gasoline in it.
Right, right. And what's the most that they've ever put, alcohol that they've ever put in gasoline? 10%, 15%, or?
Oh no, they in Brazil they run 100% alcohol.
Oh, no kidding.
Yeah, maybe 95% alcohol.
And
yeah.
so how does that work for
It
them?
works well.
Wow.
In fact, the hybrid vehicles today you can run 75,
Well,
80%.
I've got a Prius over there. Maybe I could steal a couple of gallons from these guys and put it in there and see what happens.
Yeah, maybe.
You know, this has been a real education. Thank
You're
you
welcome,
so
Bob.
much for being on our show.
You're
And,
welcome,
you know,
Bob.
It's
It's exciting. I think it's an exciting opportunity.
very exciting. You guys had a great presentation today, and
Good.
we're very excited to get this on the air. And
Hope so. Hope this grows in even more around here.
well, I'm sure it will, because this is a green state, and
Yep.
you know, this is the future.
That's right.
This is what's coming.